on our YouTube channel. So today I'll be teaching us on the derivative of functions. That is to say, I'll be teaching us new techniques which we can use to get the derivative of a function. Now let's look at this. Now the technique is that dy over dx is equals to 1 over dx over dy. Don't get confused. For example, now if I'm to find the derivative, that is dy over dx of 2x plus 1 raised to the power half. So with this, we have a shorter way to do this. That is to say, you make y is equals to 2x plus 1 raised to the power half. So your aim here is to make s a better formula. So to remove this, you multiply this by 2, then you square here. So we're having y squared is equals to 2x plus 1. Taking this here, we're having y squared minus 1 is equals to 2x. And finally, we're having y squared over 2 minus 1 over 2 is equals to x. So the next step, I'll say put it here, x is equals to this. The next step is that you find the derivative of y to x. So that is to say, we're going to find the derivative of this. So to do this, we are having here, we are having 2y over 2 minus, to find this, we are having 0. So we don't need to write that. So the x over dy is 2y over 2. So let's come back to our initial formula. We are having dy over dx equals to 1 over dx over dy. Remember that we got our dx over dy as this. That is to say, I can write it as dy over dx is equals to 1 over 2y all over 2. And it's the same thing as 2 over 2y. Don't forget, our y is equals to this. So our final answer is equals to 2 over 2 times all this value here. 2 times 2x plus 1 raised to the power half. So this is the derivative of this function here. All these all together. So it's just a simple technique that I want to show us. So let's stay tuned as I show us another example that deals with trigonometry. Example, we are looking for the derivative of the sine inverse of x. This, and we are going to use this method to treat that tender to us today. Now let's start. Remember, we see that y will be equals to what? Sine inverse of x. So our aim here is to make a subset of formula. That is, see this is sine inverse, same thing as 1 over sine. So if you multiply here by sine, multiply here by sine to balance, then I'm having sine y is equals to x, making s subject of formula. Now remember in our trig function, let's say we're having this. We want to plot, draw a triangle here. This is pi over 2. This is negative pi over 2. If I say sine theta, this will be my theta. But now we are having sine y. That is to say, y is the angle here. That is y. This is y here. Sine y is equals to x over is equals to x. Remember, we are having a visible y, that is opposite over hypotenuse. Now to put opposite hypotenuse, I'm having 1 here and I'm having x here. So using our SOHCAHTOA. Now to do this, let's look for this place here. Remember, this is the using our Pythagoras theorem, which is 1 square hypotenuse square is equals to opposite square plus adjacent square. So to look for this side, it will be 1 square minus s square is the root of 1 square over s square. Let's call this p. So this side now is equals to 1 square, which is 1 minus s square. So with this, we have looked for this angle related to this. Now the next thing we have to do is to differentiate this, that is with respect of a, that is dx over dy of this function. So the derivative of sine is cosine, that is having is equals to cos y. So we are going to bring, since this is this, we are going to say the y over dx is equals to 1 over our dx over dy is cos y, cos y. Now coming to this, to our triangle here, remember cos of this triangle is adjacent to hypotenuse. That is our cos y is equals to root 1 minus s squared over 1, which is also root 1 over s squared. So we are going to substitute that in this value. So we are having 1 over the square root of 1 minus s squared. So let's not forget this very easy techniques I showed us on how to get this, just to get the sine inverse of a function. So stay tuned as in our next classes we will show us more on how to use and on so many tricks you use to solve a function. So thank you very much for staying with you on this channel. Don't forget to subscribe.